Okay, everybody, so now, in all of the examples we've done before, we've used situations where there's only one solution, right? And there was a solution. Their solution existed and there was only one solution. What we're going to do is we're going to look at now where other things can happen. Also, at this point, strictly speaking, we don't need rescaling in order to solve the system of equations. We introduced the rescaling because we're going to use that later in a variation of Gauss's method called the Gauss-Jordan method of solving systems of equations. But at this point, we don't need rescaling to solve these. Okay. So the Gauss-Jordan method will use that. So, but let's look at this example here and see what other things can happen. So notice, first of all, that we've got three equations here, but we only have two unknowns. Okay. So let's see what happens in the method. The Gauss method is going to help us understand what is going on here. Okay. So let's go through what we would normally go through. So we're going to get rid of these, right? So what we're going to do is we're going to do -2 row 1 plus row 2, and then -2 row 1 plus row 3. Okay, let's see what that gives us. So again, row 1 is unchanged. Okay, what happens here? These are going to go away, right, by construction. Okay, so if we do -2 times 3 is -6. -6 plus 1 is -5. Okay. -2 times 1 is -2. Minus 3 is -5. Okay, and then here, -2, this is going to be -6, plus 2 is -4. And then we get -2 minus 2 is -4. Okay, and so what do we get here? Well, at this point, we can solve this, right? Okay, but let's go on, because again, we want an echelon form. So let's get rid of this one. So what do we need to do to get rid of this one? Let's do one more row operation. So we want to do what? We want to do 4/5, right? -4/5 times row 2. So -4/5 times row 2, right? And then we're going to add that to row 3. Because if I do -4/5, that's going to give me +4 here, okay? And then that's going to get rid of this, okay? And then we're going to do -4/5 here, and here it's going to give us what? 4. Okay, and then 4 plus -4 is going to be 0. So what happens here? Well, we end up with x plus 3y equals 1. We get -5y equals -5. And we get 0 equals 0. So what happened? Okay, so what is it 0 equals 0? Well, this 0 equals 0 here represents or indicates a redundancy. Okay, what does that mean? It means that we had two equations in the system that were basically the same equation. Okay? So in the case where we have this situation, well, it means that, hey, one of the two equations was unnecessary. Okay? So in this case here, these two equations were pretty much the same thing. Okay? Because you can multiply one equation to get this equation. Okay? Or excuse me. Oh, I'm sorry, this equation. Right? So, or these two here. Because as we see here, I multiplied just by -4/5, and what happened? I got the exact same equation. I got +5, y equals +5. But here's the thing, I could just multiply by 4/5. If I multiply this thing by 4/5, what do I get? I get this equation here. So these two equations represent the same equation. Okay, so now in this case here, what's the solution? Well, now I can solve this. So y equals 1 and x equals -2, right? And so our ordered pair for the solution would be -2, 1. Okay, that's it. Let's do another one.